Welcome to X-ray safety training for analytical X-ray device operators. Learning objectives. This course meets regulatory requirements for analytical X-ray operator safety training. Upon completion, you should be familiar with X-ray sources and their potential health effects, how to minimize radiation exposure, analytical X-ray equipment and their safety features, applicable regulations, along with your responsibility to comply and promptly report any violation. Radiation exposure reports you may request, and X-ray operators must complete this course annually. Characteristics of X-rays. X-rays are a very penetrating form of electromagnetic radiation that travel at the speed of light and have no mass or electric charge. X-rays interact with matter in two ways. They first ionize. They strip one or more electrons from atoms, and two, they excite, which means they raise orbital electrons into higher energy orbital atoms. As the ionized or excited atoms return to their ground state, they give off the excess energy in the form of scattered X-rays. X-ray production. Bremsstrahlung X-rays are emitted by the de-acceleration of a charged particle when deflected by another charged particle, typically an electron by an atomic nucleus. Characteristic X-rays are emitted when outer shell electrons fill a vacancy in the inner shell of an atom. Radiation dose units. Regulations require expressing occupational exposure as dose equivalent in units of sievert, SV, or rem. 1 sievert equals 1 joule of ionizing radiation energy absorbed per kilogram of absorbing material, multiplied by a quality or weighing factor that depends on the type of radiation. Background radiation. We are all exposed to ionizing radiation from natural sources. These include radioactive material in the Earth's crust, radioactive gas emanating from the ground, cosmic rays from outer space, and trace amounts of radioactive material in the body. How much radiation exposure do you get outside of work? The National Council of Radiation Protection's report shows an increase in the average radiation dose to members of the US population since the 1980s, mostly due to increased CT use. Radiation bioeffects. The biological effects of ionizing radiation exposure are among the most thoroughly studied of any chemical, physical, or biological agent. The health effects of radiation exposure at various doses are very well established, and these health effects depend on both total dose and dose rate, as well as several other factors. While the subject of radiation biology is complex and beyond the scope of this course, there are significant dose rate dependencies, and we can make certain general assumptions about the health effects associated with any specified dose. There's two types of bioeffects. The first is deterministic, which means the severity of effect increases with dose. The clinical symptoms begin at about 100 rem, associated with acute or short-term high-dose exposures. Examples of these are cataracts, epilation, and erythema. The second is stochastic, which means the probability of effect increases with dose. Incidence begins to increase above endemic levels in populations given acute doses of 5 to 10 rem. Examples of this include cancer, genetic mutations, and developmental abnormalities. Occupational dose categories. Regulations specify several categories of occupational dose limits applicable to X-ray users. The first is deep dose equivalent, which is the whole body, head, neck, and torso, exposure, which is the dose equivalent at a tissue depth of 1 centimeter. The second is lens dose equivalent, which is exposure of the eye lens, and the dose equivalent is at a tissue depth of 0.3 centimeters. And lastly, shallow dose equivalent, which is the exposure of the skin or an extremity, taken as a dose equivalent at a tissue depth of 0.007. Annual occupational dose limits. We are required to keep occupational doses below. Dose limits in perspective. Occupational limits are below doses known to cause these bioeffects. ALARA. In addition to ensuring that occupational doses do not exceed the occupational limits, Regulations also require that Kentucky keep such exposure as low as reasonably achievable. ALARA. As radiation workers, you are required to keep your occupational radiation dose and the radiation dose to others as a result of your radiation use. Radiation protection principles. The first is time. Limit time near the source. The less time a person is exposed to radiation, the less dose is received. Dose is equal to the dose rate times time. Distance. Stay as far as feasible from the radiation source. Increase the distance between you and both the X-ray tube and the tube side of the patient. And lastly, shielding, which is to block radiation with appropriate shielding material. There's two categories of analytical X-ray equipment. The first is enclosed beam X-ray units. The primary X-ray beam is shielded by an enclosure. And the second is open beam X-ray units. The primary X-ray beam is not shielded. Analytical X-ray equipment safety features. Analytical X-ray devices are required to incorporate standard safety features that include interlocks, shutters, enclosures, and fail-safe warning lights. These equipment design features help protect operators from accidental exposures. Interlocks. Interlocks are a set of switches in a series, where every switch must be closed in order for the X-rays to be generated and/or for a shutter to be opened. These switches are connected to doors, panels, and collimators, which if opened or removed, would create a radiation hazard for the user. If any switch is opened while the X-rays are on or the shutter is open, the X-ray generator will immediately shut off and/or the shutter will close. Shutters and enclosures. Shutters open and close a path for the useful X-ray beam. When a shutter is properly functioning and closed, no X-ray can pass beyond the shutter. Enclosures are boxes. Some have a transparent window, which contain the X-ray instruments so that stray or scattered X-rays do not escape into the room. Enclosures, along with interlocks, also prevent people from exposure to the direct X-ray beam. Fail-safe warning lights. Warning lights indicate when the X-ray tube is on and a shutter is open. Regulations require these lights to incorporate several safety features, including fail-safe operation, wired so that if a lamp fails, and the X-ray tube will not turn on and the shutter will not open, ensuring that operators will always have a visual indication that the device is producing X-rays. If the warning light fails while the X-ray tube is on or a shutter is open, the tube will turn off or the shutter will close immediately. When a broken warning light is repaired, the X-ray tube will not automatically turn back on, nor will the shutter open again, until or unless the user first takes action to do so. Administrative controls. The first is safety overrides. Under some circumstances, it may be necessary to override the analytical unit's safety features. All overrides must be approved in writing by the radiation safety officer. The second is operating procedures, which are detailed written operating procedures shall be available to each registered unit. These procedures shall include all routine operating conditions for which the instrument will be used. At a minimum, this shall include sample insertion and manipulation, equipment alignment, routine maintenance, as well as emergency procedures. Operating and emergency procedures must be posted. General precautions. Always turn the X-ray beam off before attempting to make any changes to the experimental setup, and always examine the system carefully for any system modifications or irregularities. Never expose any part of your body to the primary beam. Never leave the energized system unattended in an area where access is not controlled. Never remove auxiliary shielding without authorization from the owner of the analytical equipment or radiation safety officer, and never bypass safety circuits such as interlocks. While the beam is on, do not attempt to handle, manipulate, or adjust any object, which is in the direct beam path. Radiation occupational dosimetry monitoring. Radiation workers likely to receive 10% of an occupational dose limit or working with an open beam analytical equipment are required to wear a radiation dosimetry device. Under normal operating conditions for an enclosed beam analytical device, the maximum dose rate at the operator's position is about 0.2 millirem per hour. It takes 2,500 hours of such operation a year to approach 10% of the 5,000 millirem a year limit. Thus, dosimetry monitoring is not required for users of enclosed beam analytical equipment. If you have any questions or concerns regarding your radiation exposure, contact Radiation Safety. Radiation monitoring badges. Dosimetry badges verify compliance with dose limits. To obtain a dosimetry badge, submit badge requests to your local badge representative. Dosimetry badges provide accurate information only if used properly. The wearer is the most important factor. Dosimetry badges. Where to wear. The body badge. If issued a body badge, wear it between your shoulders and waist. Ring badges. Ring badges should be worn on the hand most likely to receive the highest doses, with the label facing toward the source of radiation with which the wearer is working. Radiation badge policies. At the end of the monitoring period, exchange badges with your department's badge representative. If your badge is lost, contact your badge representative for a replacement. When not at work, leave badges in an area where they will not be exposed to radiation. Do not wear another person's badge or put false exposure onto the badge. Declared pregnant workers, DPW. Regulations allow pregnant radiation workers the option of voluntarily declaring their pregnancy to their employer, activating lower occupational dose limits. The occupational dose limit for a DPW for the entire pregnancy is 500 millirem. For an undeclared pregnant radiation worker, the limit remains the same as for all other radiation workers, which is 5,000 millirem. There is no need to modify work practices unless previous dose history indicates more than 500 millirem a year. Remember that DPW status at UK is confidential, and informing your supervisor is your responsibility. Declaring pregnancy at the University of Kentucky. Fill out the declaration form in our office, where we will provide the radiation worker counseling, literature, and a fetal radiation badge. New device registration. Are you planning to bring an analytical X-ray device on campus? Before installation and within 5 days of the device's arrival on site, you must notify Radiation Safety. This applies to all X-ray devices, whether borrowed, a temporary loaner, or a demo unit, accompanying a visiting scientist, donated, purchased, or otherwise bought on site for any other reason or purpose. Also report to Radiation Safety any changes in address, ownership, possession, or location. As an X-ray operator, regulations require that you abide by all applicable regulatory requirements, as well as the written operating and emergency procedures, that you notify Radiation Safety promptly of any regulatory violations or unnecessary radiation exposure, and that you keep all occupational radiation doses ALARA. Ensure that the device is secured against unauthorized use when unattended, and ensure written operating and emergency procedures are posted and are with the device at all times. Allow operation by only trained and authorized individuals, and lastly, perform and document a check of the interlocks and safety devices every 3 months. Who is in charge? Each organizational unit using an X-ray device must designate a responsible individual for ensuring that device is used and maintained in a manner that ensures safety and regulatory compliance. If no one has been designated, unit management is directly responsible. Regulations require you to report any situation that may result in unsafe conditions or regulatory violations. Additional considerations: XRF portable X-ray fluorescence analyzer. X-rays from the XRF unit induce X-ray fluorescence in material by exciting and ionizing atoms in that material. The excited or ionized atoms in the target material emit characteristic X-rays. The energy of the fluorescence X-rays allows the instrument to identify elements, etc., in the target material. The highest radiation level is at the front of the instrument. The highest radiation level is at the front of the instrument. Radiation safety for the XRF. Be familiar with the operating and emergency procedures before attempting to operate the device. Always wear proper dosimetry when operating the device. Follow the proper operating procedures and ensure that other users do so as well. Never hold the sample during analysis, and never allow any part of any person's body, besides the operator's trigger finger, closer than 1 foot from the measurement point during X-ray emission. It never allowed the device to be operated unless it is in contact with sample material, and never point the device at another person. Emergency procedures for XRF. If you suspect that X-ray emission continues after the measurement is terminated, disconnect the battery pack immediately, and do not use the device until it has been repaired, and immediately notify the lab manager. If there is a known or suspect exposure of a person to the primary beam, notify radiation safety and the lab manager. If the device is severely damaged, immediately remove it from service until it can be repaired and/or radiation safety performs a radiation survey to verify the integrity of the shielding. Additional regulatory requirements for the XRF. This device is currently registered only in the state of Kentucky. Use of any X-ray device in any state or country requires registering that device there. This device may not be operated outside of Kentucky unless the device is registered in that other locality, or the other locality has a reciprocity agreement with the state of Kentucky. This concludes the end of the radiation safety training. Please visit our website for any other questions or concerns and for access to environmental health and safety in Kentucky Radiation Control Branch X-ray Division.